The information for the 2005 National Electrical Code still applies to the 2002 National Electrical Code for testing purposes, specifically for load calculations. The National Electrical Code is updated every 3 years. Load calculations, which are covered in Article 220 of the National Electrical Code, have remained substantially unchanged since the 2002 National Electrical Code. The methods and formulas used for load calculations in the 2005 National Electrical Code are the same as those in the 2002 National Electrical Code. When calculating load, firstly, we need to consider general lighting. General lighting is typically calculated at 3 watts per square foot or 0.1 volt amps per square foot. This value represents the estimated power consumption for general illumination purposes within a building or space. It's a fundamental factor in determining the overall electrical load. Secondly, receptacles are considered. Each receptacle outlet is calculated at 180 volt amps. It is specified that there must be not less than 220 amp circuits for lighting and receptacle outlets. This requirement ensures that there is adequate capacity to handle the expected load from various devices plugged into these receptacles. Thirdly, appliance loads are taken into account. The appliance load is 1500 volt amps for each kitchen receptacle outlet. This applies to 2-wire, single-phase, 120 volts outlets commonly found in kitchens. This value accounts for the power consumption of typical kitchen appliances plugged into these outlets. Fourthly, electric cooking appliances are considered. For electric cooking ranges and ovens, a load of 12,500 volt amps is used. For counter-mounted cooking units, 1800 volt amps are used. These values represent the estimated power consumption for these cooking appliances, which are often significant contributors to the overall electrical load. Fifthly, electric water heating is calculated. Electric water heating is calculated at 1250 volt amps for each kilowatt of heating element capacity. This value reflects the power consumption required to heat water using electric heating elements, which can vary depending on the size and type of water heater. Let's go over a more in-depth look at load calculations, which is Article 220 of the National Electrical Code. The purpose of load calculations is to determine the minimum size of the electrical service, feeders, and branch circuits required for a building or structure. Accurate load calculations ensure safety and prevent overloading of the electrical system. There are 2 main methods for calculating loads. Firstly, the standard method, outlined in Part 3 of Article 220, is used for most residential and commercial buildings. It provides a systematic approach to calculate general lighting, receptacle, appliance, and motor loads. Secondly, the optional method, outlined in Part 4 of Article 220, is used for dwelling units. It allows for a reduced demand factor to be applied to the total connected load, resulting in a smaller service size. Now, we will go over the steps involved in performing standard load calculations. Firstly, calculate the general lighting load. This is determined by multiplying the square footage of the building by the volt amp per square foot value specified in Table 220.12 of the National Electrical Code. For example, if a building is 2000 square feet and the volt amp per square foot value is 3.5, the general lighting load would be 2000 square feet times 3.5 volt amps per square foot, which equals 7000 volt amps. Secondly, calculate the receptacle load. This is determined by counting the number of receptacle outlets and multiplying by 180 volt amps per outlet. For non-dwelling units, you must use 180 volt amps, and for dwelling units, you may use 3 volt amps per square foot instead. For example, if a building has 50 receptacle outlets, the receptacle load would be 50 outlets times 180 volt amps per outlet, which equals 9000 volt amps. Thirdly, calculate the appliance load. This is determined by adding up the volt amp ratings of all appliances that will be connected to the electrical system. For example, if a building has a refrigerator rated at 800 volt amps, a dishwasher rated at 1200 volt amps, and a microwave rated at 1000 volt amps, the appliance load would be 800 volt amps plus 1200 volt amps plus 1000 volt amps, which equals 3000 volt amps. Fourthly, calculate the motor load. This is determined by adding up the horsepower ratings of all motors that will be connected to the electrical system and multiplying by the appropriate factor from Table 430.248 of the National Electrical Code. For example, if a building has a 5 horsepower motor, the motor load would be 5 horsepower times 746 watts per horsepower, which equals 3,730 watts. Convert to volt amps by dividing by the voltage. Fifthly, after the individual loads are calculated, apply demand factors to the loads. Demand factors are percentages that can be applied to the calculated loads to account for the fact that not all loads will be operating at the same time. Demand factors are specified in Article 220 of the National Electrical Code. For example, if the demand factor for general lighting is 40%, the general lighting load would be multiplied by 0.40. Sixthly, calculate the total connected load by adding up all of the individual loads after applying demand factors. Seventhly, determine the minimum size of the service, feeders, and branch circuits required for the building or structure based on the total connected load. This is done by using the ampacity tables in Article 310 of the National Electrical Code. In dwelling units, the optional calculation method is used to calculate loads. The optional calculation method allows for a reduced demand factor to be applied to the total connected load, resulting in a smaller service size. The steps involved in performing optional load calculations are very similar to the standard calculation method with few changes. Firstly, calculate the total connected load. This is done in the same way as the standard calculation method, by adding up all of the individual loads. Secondly, apply demand factors to the loads. However, the demand factors used in the optional calculation method are different from those used in the standard calculation method. For example, the demand factor for the first 3000 volt amps of general lighting is 100%, but the demand factor for the remaining general lighting load is only 35%. Thirdly, determine the minimum size of the service, feeders, and branch circuits required for the dwelling unit based on the total connected load after applying demand factors. This is done in the same way as the standard calculation method, by using the ampacity tables in Article 310 of the National Electrical Code. The ampacity tables found in Article 310 provide the allowable current carrying capacity of conductors based on their size, insulation type, and insulation conditions. These tables are essential for selecting the appropriate size conductors to ensure safe and reliable operation of the electrical system. There are several factors that can affect load calculations. These include the type of occupancy, the size of the building, the number of appliances and motors, and the climate. The type of occupancy can affect load calculations because different types of occupancies have different electrical needs. For example, a hospital will have a higher electrical load than an office building. The size of the building can affect load calculations because larger buildings will have more lighting, receptacles, and appliances. The number of appliances and motors can affect load calculations because each appliance and motor will draw power from the electrical system. The climate can affect load calculations because buildings in hot climates will have higher air conditioning loads, while buildings in cold climates will have higher heating loads. Accurate load calculations are essential for designing and installing safe and reliable electrical systems. By following the steps outlined in Article 220 of the National Electrical Code, electrical professionals can ensure that the electrical system is properly sized and will not be overloaded. It's important to note that while load calculations remain largely consistent between the 2002 and 2005 National Electrical Code versions, other aspects of the code may have changed. Therefore, it's always recommended to consult the most current edition of the National Electrical Code for the latest requirements and updates. This will help ensure compliance with current safety standards and best practices in electrical installations. The information studied from the 2005 National Electrical Code remains relevant and applicable to the 2002 National Electrical Code specifically for load calculations.